Here we have a set math problem. Okay, let's go to the question. In the xy plane above, vertices of triangle ABC are lying on the graph of y equals to negative x square positive k, where k is a constant. If the area of triangle ABC is 27, what is the value of k? Okay, here we have a quadratic function and its graph is a parabola that we have in the xy plane over here. Okay, now let me take the given quadratic function as it is. It is y equals to negative x square positive k. This quadratic function is in standard form, that is y equals to ax square positive bx positive c. Actually, the x term is not in the given quadratic function. It's not a problem. When we have a quadratic function in standard form, that is y equals to ax square positive bx positive c, the constant we have over here at the place of c represents the y-intercept of the parabola. So here we have constant k in the given quadratic function. So this constant k represents the y-intercept of the parabola. Okay, the given figure, the y-intercept of the parabola is a point C over here. That is a point at where the parabola intersects y-axis. Since this k represents the y-intercept of the parabola, the value we have on the y-axis at the point C over here is k. Now, to get the two y-intercepts A and B of the parabola, what we have to do is we have to plug in y equals to 0 into the given quadratic function. Because at the x-intercepts, the y coordinate is always 0. Okay, now let me plug in y equals to 0 over here. Then we get 0 equals to negative x square positive k. Now we have to solve for x in this equation. Let me add x square to both sides of this equation. Let me do it. Then this negative x square positive x square will cancel out. On the left side of the equation, I'm getting x square. On the right side, we have a k. Now, to get the exponent 2 over here, what I have to do is I have to take square root on both sides of an equation. And here the square root and square root cancel out. When I take square root on both sides of an equation, for the square root we have over here, we have to consider positive or negative sign. Let me write it. Okay, here on the left side we have x, on the right side we have positive or negative square root of k. That is, we get two values for x. One is x equals to negative square root of k. So here in this positive or negative sign, we consider negative sign. To get the second value of x, we have to consider the positive sign over here. That is x equals to positive square root of k. So that is, we get two x-intercepts for the parabola. Okay, here one of the x-intercepts is negative, that is negative square root of k. So we'll have this negative square root of k at the point A over here, because this is a negative side of x-axis. So the value we have on the x-axis at the point A over here is a negative square root of k. And this is a positive value, and we'll have this x-intercept at the point B, because this is a positive side of x-axis. So the value we have on the x-axis at point B over here is a positive square root of k. Now, let's consider the length of the line segment OB over here. Here we have the origin, and here we have the value square root of k. Then the length of this line segment OB is this value, that is square root of k. Now, let's consider the length of the line segment OA over here. Here we have the origin, and here we have the value negative square root of k. When I consider the length of the line segment OA over here, it has to be positive. So we have to consider this value with positive sign. Then we get square root of k as the length of this line segment OA. Then what is the length of the line segment AB? To get the length of the line segment AB, what we have to do is we have to add the square root of k and square root of k. That is, we have to add the length of AO and OB. When I add the square root of k and square root of k, I am getting 2 times the square root of k. So this is the length of the line segment AB. Now let's consider the length of the line segment OC over here. Here we have the origin, and here we have the value k on the y-axis. Then the length of this line segment OC is the value we have on the y-axis over here, that is k. And at the point of intersection of x-axis and y-axis, always we have right angle. Now, this OC represents the height of the triangle ABC, and this AB represents the base of the triangle. Already we have the area of triangle in the question. That is, the area of triangle ABC is 27. Okay, now let me write the stuff over here. That is, area of triangle ABC equals to 27, and we know the formula to get area of any triangle, that is the base multiplied by height divided by 2, and it is equal to 27. Okay, we know that AB represents the base of the triangle. Its length is 2 times square root of k. We can plug in this 2 times square root of k for this base over here. Let me do it. 2 times square root of k. And this OC represents the height of the triangle. Its length is k. We can plug in this k for height over here. Then we get k over here divided by 2 equals to 27. Okay, here this 2 will cancel out. We get square root of k times k equals to 27. And we can write the square root as an exponent. When I write the square root over here as an exponent, it will be 1 over 2 times k. And for this k, we don't have any exponent. If there is no exponent, we can assume there is exponent 1 equals to 27. Okay, here we multiply two powers with the same base k. Whenever we multiply two powers with the same base, what we can do is we can take the base ones and we have to add the exponents. Okay, now let me add the exponents. That is 1 over 2 positive 1 equals to 27. Okay, here k equals to, we add a fraction and an integer. Whenever I want to do addition or subtraction between a fraction and an integer, I have to multiply the integer by the denominator of the fraction. Once I'm done with this multiplication, I can take this denominator 2 as a common denominator. Okay, now let me do it. 1 positive. When I multiply this integer 1 by this denominator 2, that is 1 times 2 is 2. Since we have multiplied this one and this one, now we can take this 2 as a common denominator equals to 27. Okay, let me continue over here. We get k to the power of 3 over 2 here equals to 27. Now, to get rid of the exponent 3 over 2 here, we have to raise both sides of this equation to the power of 2 over 3, which is a reciprocal of 3 over 2. Okay, now let me raise both sides of this equation to the power of 2 over 3. That is k to the power of 3 over 2 is raised to the power of 2 over 3. On the right side, 27 is raised to the power of 2 over 3. Okay, here we have the base k and we have the exponent 3 over 2. And for this complete stuff, we have the exponent 2 over 3. That is, a power is raised to the power of 2 over 3. So whenever a power is raised to the power of some value, what we have to do is we have to multiply the two exponents we have over here using the power of a power rule in exponents. Then we get k to the power of, when I multiply these two values, I am getting 3 over 2 times 2 over 3. On the right side, we can consider the base we have over here, that is 27. It is a power of 3, that is, this 27 can be written as a 3 to the third power, and we can take this exponent over here. Now, let's simplify this one. Here, this 2 will cancel, 3 will cancel out. We get k to the first power on the left side. K to the first power is just k. And here, the same thing, that is power of a power rule. We have to multiply these two exponents over here. Then we get 3 to the power of 3 times 2 over 3. Then this 3 will cancel out. I'm getting k equals to 3 square. The value of 3 square is 9. Okay, here I got the value of k. It is 9. We find 9 in answer choice B. The correct answer choice for this question is B.